Okay. So besides Swiss traditions, today we're going to talk about something dear to my heart, and I volunteered to take this topic. We're going to talk about anti-patterns and refactoring. A little bit about my background. I'm not Swiss, I'm Austrian. I did my bachelor's and master's in Vienna and a little bit in New York. And I also worked on the side a little bit. So a little, maybe quick statistics in the room here. We're a nice little group, we can do this. So how many people have worked on the side? How many people have programmed on the side in here? Okay, we have 1, 2, 3, 4, around 7 people. Okay, it's not too bad. I've worked on the side as well. I worked around 3 years in a small company, and then also some internships in bigger companies. So I've seen my fair share of things that are going on in code bases. And in this lecture, I'm going to keep it snappy so you can enjoy this whole beautiful day. We're going to talk about things not to do. And I'm number one in this because I've done so many things wrong. And I want to keep you from doing things wrong. So I suggest in this lecture, for those of you who have programmed in companies, but also have programmed in other lectures, for instance, let's indulge in things we did wrong, okay? Let's talk about things that shouldn't happen. This is in Central Europe and in other parts of the world as well. People always talk about the good things. We always talk about, oh yeah, I did this great thing and this great thing. We never really, in public at least, talk about, oh yeah, I suck at programming because of this. I did this thing wrong. But I learned from this. So it's a good thing to talk about failure and talk about anti-patterns. So I think this is a good start to a dialogue that should continue in your professional career as well. So let's talk about, before we talk about anti-patterns, let's talk about design patterns first. So what is the history of patterns and what are patterns actually? And patterns actually didn't start in software development, they started in architecture by Christopher Alexander. And this is an Austrian guy, actually, an Austrian architect. And the pattern itself, the term, came from architecture. If you see certain buildings, you see certain things, how they're built, there are certain patterns that you move on to other buildings. And so this started in architecture, but then it came over, the popularity of this term came over to software engineering and software development with the book that you all maybe have heard about. It's called The Elements of Reusable Object-Oriented Software by the Gang of Four. And the first author, coincidentally, is probably the most famous alumni of the University of Zurich. So Gamma was actually here at the University of Zurich. And I think now it's at IBM, but I'm not sure. And this was published in 1994. And if someone talks about design patterns, they always talk about this book usually. I mean, there's certain books that came after this that are in some extent, are better or worse. But this book is the one that everyone knows. And fortunately for Gamma, he's known. The other 3 guys, no one has any idea who those guys are, right? So the story of this is always be first author. No, kidding. Anyway. And so let me just read this quote because I think it's a really nice quote from a different book. And it says, a design pattern is a general, reusable solution to a commonly occurring problem in software design. A design pattern is not a finished design that can be transformed directly into code. It is a description of or template for how to solve a problem that can be used in many different situations. So a design pattern is not something you would use in Java, for instance, and you have this specific code and you copy paste this. This is how a lot of blog posts work, right? But what those blog posts do is they take the idea of this design pattern, this template, and apply it to a very certain problem. So if you learn about design patterns, you're not learning a very specific solution, you learn about a concept, an idea. And you, as a smart person that you are, studying computer science or information systems, you apply this to a programming language, a system, and so on and so forth, or to project management. So this is what design patterns are. And why is this actually something that we want to have in software development? It gives us common vocabulary. This is, I think, the best thing for working in a group. If you talk about certain concepts in software development, and they're usually design patterns, you have a joint understanding of what's going on. If I talk about singleton, you probably know what singleton is. If I talk about the factory pattern, you know what factory is. Because you learned it in some book, you saw it in some blog, or maybe you can read upon it. If two people are talking about the factory pattern and you don't know what it is, you quickly Google it, or you can ask them. And it brings a common understanding on what certain things are and what certain things are not. And the other points are legit as well, because what you get is something that has worked in the past, and you can reuse it over and over again. It's something that is proven to be a good solution for a certain problem. And of course, this encourages you to write more maintainable code, because the more people understand the code that you write, the more people can actually reuse the things that you did and not invent the wheel again. Yes, and this facilitates reusability, adaptability, extendability. So those are all things about maintenance. If you talk about design patterns, we usually talk, the consequence of design patterns is your software becomes more maintainable in the end. If you look at the code again, you're more likely to know what's going on. You're more likely to have a conversation around this code. Now that we have this covered, what patterns are, let's talk about what anti-patterns are. So a recap, patterns describe commonly occurring solutions to a problem that generates a positive consequence. So this is a good thing. We apply patterns, and in the end, we have more maintainability, we can have a conversation, we have better code. And anti-patterns describe commonly occurring solutions to a problem that generate negative consequences. So anti-patterns are things where you think, oh, that's actually a good idea. This is actually something we want to do. And you do it over and over again. Or you do it once in your code base because you think, oh yeah, that's actually a good idea. But it's actually not a good idea. It generates negative consequences. So in the end, your code is not maintainable. Your code is not legible. And the conversations you have around that code are usually not positive. So today, we're going to skip the positive part, and we're going to do more fun things. We're going to talk about negative consequences. And in this, I'm going to talk a little bit about my experience, and I would like to hear about your experience as well. So before we jump into the concrete anti-patterns that we're going to talk about today, let's talk about why anti-patterns occur. Why are we doing the bad thing? Are we bad people as software developers? No, there are certain reasons to why we do the bad thing, why we indulge in anti-patterns. And number one, I think, and everyone has had this, be it in work or at the university, it's haste. It means that you're stressed. It means that you have 7 classes at once. It means that the deadline is tomorrow because you, I don't know, wanted to sleep a little longer, or you had other 5 things to do. Unrealistic targets. And with this haste, with this doing things in one day, or I oversaw the deadline, or I have other 5 things to do, what happens is you don't have an eye on quality. What you do is, I need to get this done somehow. I need the interface, which is mostly 10%, but this is what people see, to be okay. But what goes on in the background, I don't care. I have to get this done now. And this is the thing that happens a lot of times in companies as well. You have the salesperson, of course. They have their aims. They want to sell a lot of software. They want to sell a lot of project management and solutions for the company. And then this guy comes in telling you, oh yeah, I sold this content management system, very concrete example that we have. But I also sold individually to pre-programmed modules for this. And then we need to get this done in 3 weeks. And then you're the only programmer available for this task, and you have other 2 projects going on. And you say, this can't be done. How should I do this? Well, you have to. You all had this before. Come on, I can see it in your faces. We all had expectations that we could not meet with certain quality. And we don't compromise with what we need to do, because that's in the contract. The contract says we need to do X and Y. Good contracts say we need to do X and Y with a certain quality. But usually contracts say we need to do X and Y. And you're saying, but I can only do X in 3 weeks. And your salesman or project manager is saying, you have to do X and Y in 3 weeks. And this is how a lot of anti-patterns occur, because you don't really care about quality. This is the one part that usually suffers if you are in haste. Number 2 is also true for a lot of people. Apathy. Apathy is a very, very beautiful word in the English language, and it usually says lack of interest. You don't really care about this. You develop software or you develop a solution, but you don't care about, you maybe care about the outcome, You maybe care about the people see something that is nice, but you don't really care about solving the problem in a way that is beneficial to your future self, maybe, or other people. Because usually what that means is you don't care about you maintaining the software in 6 months or in a year or someone else. Maybe you're just a contractor and you're like, okay, I'm gonna do this in the cheapest way possible, and I'm out of here. I'm going to the Bahamas anyway. I'm out. Okay. So apathy is a very very difficult way to assess this problem of anti-patterns, because you know there's a good solution out there. It's not that you don't have time. You're like, I don't really give a shit. I don't care. Okay. So it's the unwillingness to solve those known problems. You're not even picking up a book or looking at something. You're like, I'm going to do this my way because I don't care. Narrow-mindedness. This is true for smart people and not so smart people alike. It's the refusal to practice those solutions that are known as patterns, that are known to be effective. Because, again, it could be apathy. It's you don't care. Or it's maybe because you know better anyway. You're that guy who's like, yeah, all those people before me, those are idiots. They don't know what they're saying. So you do the thing on your own. Or it's the apathy part. But narrow-mindedness, it's usually the pattern where you see someone saying, I know this better than anyone else. Sloth and laziness. Yeah. Is that what is sloth?
It's an animal too.
Oh yeah, right. Exactly. Yeah. So laziness. It's like, okay, I can do this. I can do the right thing, but the right thing takes a lot of time and a lot of effort, and I'm gonna look at this again. And quality takes time, and quality takes a lot of nerve and a lot of brain power. And many people are like, you know what? Let's skip this. Let's do it. Let's hack it. Okay. So laziness is making decisions based on an easy answer, and a lot of people do this, of course. Greed. This is something that I didn't know before. Before I got into this topic a little more in depth, and this is something that junior developers, I think, suffer in a lot. They take a bottom-up approach of designing software. I think I get a lecture in the beginning of the semester about software architecture and how software architects need to focus on the big picture, right? You need something that lasts for a couple of years at least, or longer actually, if you look at big software. And what this avarice and greed part of root causes of anti-patterns is that you go and jump into the details right away. It means that you're not looking at the big picture, you're not looking at something that could last for longer, you're looking into the details of software design. And this is good, it's not a bad thing per se. It's a bad thing if you don't focus on the big picture as well. There needs to be a certain balance of focusing on details and focusing on the big picture. So this is what this greed part means. So what you need in software architecture and software design is a certain level of abstraction that you work on. If you bite yourself into details, those details are going to be thrown away in a couple weeks anyway. We see it in our bachelor courses on software engineering, that people maybe focus a lot on details, and then they have to rewrite the whole thing anyway, because most of the times it doesn't turn out the way you think it will in the beginning. So software design is a little bit about strategic thinking and not so much about the greed of modeling excessive details. Ignorance has also to do with laziness, I think, and apathy, because ignorance is not really an excuse. Not knowing any better in times of internet is, I think, the worst excuse ever. I can imagine people in the 80s who programmed, or even the early 90s. The internet was not too well known then, or not existent, where you had to actually have the books and have the literature and have the information in the company to do certain things, to know the good solutions. But nowadays, if you suffer from ignorance, you're just lazy, or you're apathetic to the problem. But basically what ignorance is you don't know any better. You just start along programming, maybe it's your first semester at university, you don't know the resources, and you just start along programming, and you do the things your way, which usually, let's face it, our first programs weren't the best, right? Every year you look at your old programs, maybe, or maybe you don't, but I look sometimes at my old things, I'm like, oh my god, this is terrible. And maybe you did things like this yourself. You're becoming better every year. Um, and also, there's a lot of information out there you didn't know about maybe, but if ignorance at the first place, you don't know anything, and you do the solution is your excuse, then it's just laziness or last slide apathy. The last one is pride, which also correlates with this narrow-mindedness, I think. You maybe heard about this before. It's not only in software engineering or software development. It's a not invented here syndrome. A lot of, I think, engineers in general suffer from this problem. It's not my solution. It's not my pattern. It's not my way of thinking, and that's why it's not good. This happens even more in engineering. I think I talked to a lot of friends that are in mechanical engineering and that also work at big companies now. And what they're saying, it's insane how commonly known problems are reinvented. So the wheel is reinvented for things that we have known for 20 years how we should solve this. But this one specific use case has not been solved by this before, and that's why we need our own solutions. And this is also, this pride thing, I think, is a very dangerous thing to have in software development. Especially if you start out in the beginning, you don't know best. Let's face it, you can be a genius, but still, there's so much wealth of knowledge out there. You can't know everything. So I think pride and this narrow-mindedness are probably the most dangerous things that could happen in software development in terms of anti-patterns. All right. So we're going to talk about 3 types of anti-patterns today. So now we heard about what are the root causes, why are we doing the bad thing. Now a little intro onto what exactly are the things we're going to talk about today. And for the one part, we're going to talk about software development. So this is the thing where you're a programmer and we're facing a certain problem and you need a solution. So we're going to talk about anti-patterns in this regard. We're going to talk a little bit about software architecture, so a little more high level. And then, because we're in information systems as well, we're going to talk about project management. So those are things that I'm mostly concerned with. Communication in the project are concerned with people issues, I would say. And in there, I'm going to also talk about a consulting project we had last year, which had very funny outcomes. But in general, we're going to focus more on the software development parts and the software architecture parts, but we're briefly going to cut on the project management. And there are a lot of things here. We're not going to do the whole laundry list, okay? So if you can see it, we're going to talk about 1, 2, 3, 4 things in detail in software development. We're not going to do the whole thing. If you want to know about the whole thing, yeah, there's some very funny. I can see you laughing. There's some very funny names in there. Poltergeist, right? The Golden Hammer. Jesus, it's going to be certain movie names. But we're going to talk about the blob, lava flow, spaghetti code, and singleton because I think those are the certain things that you've seen before, I think, and you can maybe relate to a little better. And the other things you can look up in the internet, right? Don't have the ignorance part of the root causes. All right, the blob. The blob is my favorite one because in the first company I worked in, our architecture suffered from the blob, and in turn, my software development skills decreased of working in this company. Okay, so usually if you're saying experience is a good thing, it always is. But if you want to advance in software development, you should have people in the project that are better than you. Number one, this is the one thing I can tell you out of my experience. If you want to learn from software development in a company, have people that are better than you in the company. Have people that if you do something, if you design something, tell you this is terrible. What have you done, right? So I didn't have this at this company because we suffered from the blob. And the blob is, we had OOP, we worked in this case PHP, but object-oriented, we also had some Java in there, and I think some Visual Basic, which was terrible, but still, we had some object-oriented systems, and what the blob is it's a misuse of OOP, object-oriented programming, for something that is actually procedural in its nature. And what it is you have the majority of responsibilities of your whole system. It was a big system. It was a content management system for mid to enterprise sized companies. So we did a lot of interactions there, a lot of things that came together. So it was a big software actually. But what we did in this company, what other companies do as well, is they had maybe a handful of classes, maybe 10 classes, and their whole business logic was crammed in there somehow. And that's an issue. So what you get then is complex controllers. So if you think back on model view controller of that pattern, we used model view controller pattern, but basically our controller did everything. Yeah. So, and we had many data object classes that did nothing that you would do in object-oriented programming. You had data objects to actually hold data, which sometimes makes sense. In this case, it didn't. And if you only have objects to hold data and they have no behavior on them, that's not object-oriented. That's not the meaning of this. And we had a separation of process and data. That's the thing, basically. If you know a thing or two about object-oriented programming, that's the opposite of object-oriented programming. You have the data coupled to behavior. That's what object-oriented programming is. So what we had, it was actually procedural. So the symptoms of this, I touched on this before a little bit. You have a single, if you look at a certain part of the product, you have a single class with very high complexity, a couple of thousand lines of code. It was really terrible. So if you scroll from one end to the other in those classes, it takes about a minute, okay? So it was that bad. And you have certain lack of cohesiveness. So certain parts didn't make sense in the class, and then other parts, so it was basically bound to be refactored, but no one did, by the way. And this happens usually if you want to migrate some legacy design. You had something in Fortran, you had something in COBOL maybe, and you're trying to migrate the design of this into a more modern Java C# approach maybe. That's what I've seen in the past in consulting gigs. Many people had their old legacy things and wanted to move them into the new era of software design. But software is huge and time is limited, as I said before. So what they did is they actually just copy-pasted the things, and everything that was Fortran became Java, but it was still procedural. It wasn't object-oriented. And the issue is, and that's the beautiful part, it was too complex for testing anyway. You couldn't, the reuse was there. We had this whole thing in Java and not in Fortran anymore, but it was too big to actually test. Yeah, we didn't know where to start testing. We didn't know what was going on. In some cases, we didn't even have classes to begin with. We went into PHP directly. So if you know a little bit about PHP, what you can do is basically, if you open up a PHP file, you can get stuff from the database, do some logic on them, display them in one file. Okay? Yeah, I see people like, yeah, I did this before. Okay? I did this too. Guilty. All right? And it's terrible. And the beauty, I saw a beautiful quote on Twitter on this. You can't have unit tests if you don't have units. Okay? We didn't have units. A lot of projects out there don't have units. So how can you test something that is just a big blob, thus the name? Yeah. So we talked about root causes before. Let's talk about root causes here as well. Usually it's lack of architecture, I would say. So in the case of PHP, definitely lack of architecture. So how this came about is you start with small parts. You start with a script that does something. Then your project manager comes in and you show him the script, like, hey, we can do beautiful stuff with this. And he's like, oh, can we sell this to clients? Yeah, maybe we can do that. And let's build a prototype on this. And you build a little bit around that little script. You build a GUI or something. It's still in the same file. It's a script. And then this goes on and on and on until you're selling 1,000 units of this to people. And people are actually using this. But you have 0 tests. You have 0 architecture. It was just a script in the beginning, right? But you program a little bit here, and you program a little bit there, and you don't reevaluate saying, oh, we should stop this now. We should actually sit down and think about an architecture that is sustainable. But if things happen incrementally, and I'm very sure you had this before in your projects, and what happens is you don't think about your future self. Because your future self is going to maintain that, and it's going to be terrible. And it's going to be a nightmare. So my little advice for you in this, even if you start out small and you're reevaluating the whole thing, you're adding new functionality and you're adding user interfaces, what you should do is sit down and take a step back and saying, is this going to be a nightmare 6 months from now? Is this going to be terrible for me and my whole company and people after me? Am I going to get death threats on this? Okay, this is, all right. So this is the line of reasoning you should have if you evolve a system, because it usually starts out small and then it becomes the blob. Oh yeah, so this is an example from antipatterns.com. So this is about the library, and what it does is basically hold some data. The item would be a book or a magazine or something, and you have a person here, and everything around the software is concentrated in this here. And if you look at this in the first glance, you're like, it should be fine. It's just a library, right? It's just maybe 10 people letting out stuff and like this. This can become a monster very quickly. And this is already a little bit of a monster because I have no idea what certain things here do. And this class here, I'm very sure if you type it out and if you look at antipatterns.com, I think they have an example, has a couple thousand lines of code. Yeah. And they do database manipulation here. They display the view here. There's cohesion. There's too high of cohesion, but there's no modularity. If you want to change the database here, you have to go through all the code in this class and change the database statements and change the adapter. If you want to have a different front end, good luck. The front end is going to be the same. It's only going to be HTML. You're not going to be able to roll out a mobile client in this, for instance. So this is an example of how the blob could look like. It's still a small example. I've seen way bigger. Maybe you've seen too. So maybe a quick round of hands. Who has seen the blob in action? All right, so we have 1, 2, 3, 4, 5 people. Okay, maybe some, right? So if you haven't worked on huge software before, even in really big companies, this is a anti-pattern that is there. And then it's something that one person did, and that person is not at the company anymore, and you're not touching that code. You're like, holy shit, it has 5,000 lines of code. I have no idea what this does. Let's keep it like this. Okay. So those things, if you see them, you don't want to refactor them if you're not the author. And even if you're the author, that's the kind of terrible part about software maintenance. In 6 months, or even a couple months after this, it's not even your code anymore. If you haven't looked at this kind of code in a long time, you don't remember what you did there. It's terrible. So avoid the blob at all costs.
I have a question.
Sure.
But what's the key recipe to not end up in the blob? Because I think that's kind of difficult.
It is difficult. You're right. So what is the key? I'm guessing reflection. It's actually sitting down and saying, where is the software going? Because usually a blob doesn't start as a blob. A blob starts as small scripts, right? Or so what is your experience? How does this start?
Yeah, because my experience always was, well, as you said, I have model classes where the data sits, and I have some logic that really has to do with this single data class.
Yeah.
And then at some place, I need to have the logic, and in the end, it all depends on everything, and I need to have this central class that does all that.
The God class.
Yeah, and that I know that it's bad, but I'm not really a good idea how to make it better.
Right. So if this is already in place, those things are things we can do. So if you quickly iterate this, I'll come back to your question. So if you have the blob already in place, what you can do is actually sit down and say, this is going to bite me in the ass soon. So there needs to be some kind of reflection. So if this already exists, you need to think about how this is going to be bad for me in the future or for the company in the future. So you need to apply the object-oriented principles. So I don't know, do you guys have an OOP class? Have you heard about OOP? Yes, no, maybe? Okay, a few have. So if you don't, then I would really recommend, if you go into software development, get some knowledge about the principles of object orientation. And those are usually separation of concerns. Don't have one class for everything, but have one class that does one thing good for this domain. So if you go back quickly here, we have certain different concerns here. We have, number one, we have the same domain, but in this domain we have different subdomains. We have the item, we have catalogs, We have library cards here. So in here, for instance, I can, in a quick glance, I can already see we have 3 different subdomains that we're tackling in one concern. What we also are tackling is we're tackling the inventory, we're tackling checkout, we're tackling printing the whole thing, sorting, etc., etc., etc. Those are all different concerns that should be separated. They shouldn't be in this one class. There should be one class that handles one of those things. Then you can actually reason about this program. If I look at this program, reasoning becomes hard. If you have one thing and you do the one thing well in that one class or one module, one package, then this is something that you can work with. So separation of concerns, I think, is even if you start programming, is something that you always should think about. Is this class doing too much? Do I have too many concerns in this? Am I handling the database and displaying the view, as in the PHP example before? I'm doing something wrong. I should refactor this in more classes, or more modules at least. This goes hand in hand with distributing the responsibilities. The responsibility would be here, for instance, take care of the database, take care of external services. For instance, you connect to Facebook or you connect to Twitter, as I heard before, to get some tweets, for instance. And most importantly, and this is also important for testing, isolate the effect of changes. Okay? If you change something in a blob kind of God class, then if something goes wrong, if something happens in your class, it's very hard to isolate what actually caused this. If you have separation of concerns and you distribute the responsibilities in a more uniform way, then what also happens is in testing, be it automated or non-automated, you can pinpoint to the problem more quickly. All right? So this is remove unnecessary dependencies. I mean, this is always a good thing, but this is it's easy to read this from a slide. It's more hard if you have a legacy system and you have dependencies where you don't know if they're still intact. If you're calling a certain legacy system and it was built 10 years ago and you have no idea what's going on in there, you also have no idea if you can throw it out. But there's also where good testing comes in. If you have good testing going on, good automated testing going on, you can try throwing away stuff without having the headache that this is going to bite me in the ass in production, with people then crying that something's not working. If you have good tests in place, this is the first and probably the most important thing to start those refactorings. So going back to your question, if you already have the blob in place, look at those here. If in the process of becoming the blob, you should have in mind that certain things should be designed in a way because they have to apply to those principles. Separation of concerns, don't do too many things at once, right? Have different responsibilities, and so on and so forth.
Would you say that that applying the solid principle, that means a single responsibility, Liskov substitution principle, and all these acronyms, is that the main countermeasure against the blob? Or
Right. I mean, solid is very much specific to object orientation. Definitely, solid is the number one thing. But if you apply the Liskov thing, then good. It's not bad. But I think the number one thing is the separation of concerns. If you look at certain, it doesn't have to be object oriented. Now we have the example of object orientation because it's the most prevalent thing. If you work in functional programming or also procedural, if you're in C, for instance, look at the unit. The unit could be a class, could be a source file in C, for instance, or could be a module in certain other programming languages, and ask yourself: is this doing one thing or is this doing n things? If it's doing n things, reevaluate. Why is this doing n things? Is it because I was lazy? Maybe is it because I didn't know any better? So what was the reason for that? And then say, if I separate this one concern out, would this make my code better? Would this make my code more readable? Could I test this better? And so on. So I think the solid principle is very good. I think that's a valid point if you are in OO. If you are in functional programming, for instance, separation of concerns and all those things here also apply. Solid is very much, so if you haven't heard about solid before, definitely look it up. One of the most important things you can do in OO.
Yeah. I have another question.
Sure.
But I mean, because many things are kind of procedural. If I think of an order, for example.
Right.
So
They have a certain workflow to them.
So I need to go to the stock and the payment and the customer and
Right.
the shipment and I don't know.
Right.
So don't I need a single class or function that processes this order process? Or how does it work? Or can I just do it by messaging different classes because that's the idea. I always went to the OO programming class, and I also know Solid. That's this one big question that isn't answered to me.
Okay.
How do I do it if I have this process and I don't know how to do it without separation of concerns, without having a single point that controls these concerns. I know that I can put some logic down to smaller parts, but in the end I always need to have one single point of entry, right?
You do have, yes, exactly. You do have to have a single point of entry, but the single point of entry, does it have 100 lines of code? Or does it have 3 lines of code that separates the workflow in different directions that you can actually manage? I think in this case, you're totally right. It's difficult because if you have an order, there's so many things that you have to know. You have to contact the payment service. You have to contact the inventory. You have to contact maybe the customer service and stuff like that. So there's a lot of things you have to do in this process, but it's one single process that has sub-processes, has subroutines. So even if you're in a procedural programming language, there are ways to separate those concerns. But in the end, you have one entry point, and this entry point should only be there for controlling those parts. It should not have. This is also a concern, by the way. If you think about this in a different way, this is also a concern you can look at. The concern being, I have to distribute my data flow. I have to distribute the way that I control those streams, and in the end, they have to all come back to me. And if you think about more sophisticated ways of messaging, be it asynchronous, for instance, then this becomes a little harder, even. Because you have your synchronous things, then you also have your asynchronous things coming back at some point, and you have your callbacks and so on and so forth. So this gathering of information from different points of systems that you need to touch upon, this is also a concern that should be in one class. But this is the only concern that you need to do, right? If you have an external customer service and you have an external inventory, and you're contacting those to submit an order, for instance, then this submitting and organizing the information should be the only thing this class does. It shouldn't at the same time also, let's say, get the most exclusive deals, right? This is a different concern, different class. Does that maybe answer a little bit?
Sense, yeah, that makes sense.
Yeah. It's a very abstract view on this. I'm sorry about this. We don't have a concrete example, but maybe we can talk afterwards if you want.
Thank you.
Okay. You got a question?
I think if you follow OO principles very strictly, there are also solutions for procedural problems as well, like strategy pattern or something like that, which encapsulates very procedural things in object-oriented design quite well.
Yeah, definitely.
You just have to do it from the beginning, because I think doing it after the code has been written is much harder than.
It is, but you sometimes have to, right? A lot of times, if you work in certain bigger companies, when you start programming, you're never gonna write new code from scratch. It's almost always maintenance. Yes.
I mean, also like a problem is that usually when you start a software system, the scope of the system is much smaller than like the software will be in a year or two.
Exactly.
So you can design your software with all the old principles that you would like to have and like to fulfill, and after a year, your design does not match the requirements anymore. So I guess you cannot like prevent the blob from the beginning, but it is a process.
It is definitely a process. This is a very good comment here. I think this whole reevaluation of your architecture and your designs is very important, because as Dominic said, your software is going to grow. As the example I said before, the script is a very famous example for me, because that's actually how I started out a certain very small project for myself, and it became a product. And some poor soul in Austria has to maintain this now. Okay. But yes.
The question I have, rather, is sometimes you, how to put this, you have like budget constraints and your customer wants like certain features, and
Right.
you know that if I would do them correctly and refactoring my software to fulfill the features, this would cost the customer more
Yeah.
than when he just goes to another like company and builds it from scratch.
Yeah.
And should you like make the customer just pay for your refactoring because that would be the way you have to do it?
Yeah.
Or I mean that's maybe the problem I often run into.
It very much depends on your project. If your project is all of the time scope of your project, is it I'm going to deliver the software and then fire and forget? Or is it I'm going to have a contract with this company for the next 5 years? If the latter is the case, I think it does make sense to charge the company for those refactorings with the proposition that this is going to save you costs in the future. And I know of companies that follow two ways of this. The one way is the fire and forget, being that we need to be competitive, and that's why our software is going to cost X amount of money, and we're not going to do those refactorings, and we're going to deal with this later. So what you're incurring here is technical debt, right? And technical debt is something that you're borrowing from the future because you're not refactoring. You're building this kind of weird solution that works, but will bite you in the ass in the future. So you're borrowing from the future because you have to solve this problem in the future. If you don't want to have technical debt, then you refactor right after you built the solution or after not so much time has passed. But then this costs more for the company or for the customer right now. And many companies go the way that you just mentioned, that I'm just going to do it that way so the costs stay at a minimal point. Other companies that I know of that are in business for quite a while now, and what they do is if they sell products on a longer scope, so on a small scope they do the same thing. They're like, okay, if it's going to be done in a year, then we're out of here. We have to stay competitive. If they're going to stay in the project for 5 years or longer, or even 3 years, I think, what they do is they sell those refactorings and they sell those improvements on maintenance as we're going to reduce the debt in the future. And it kind of works and it kind of doesn't. If the project manager has a software engineering background at the company side, then this totally works because they're like, oh yeah, I know about this. I know this concept and I totally know what you mean. You can charge the refactorings because that's what we want to have for quality software. If the sales or project management of this other company are not technical in a sense and don't know about this problem, they're like, but can't you write it good at once? Why do you need to work again on this? It's a problem in understanding rather than a problem in, let's say, sales or anything else. Or I don't even know how to put this. It's a very difficult problem. I agree. So, but I would say if you stay longer in a project, you can totally sell this to customers. If you are there in the short term, it's very, very hard. All right, good discussions here, and we spend a lot of time on this. We have other parts as well. Any other questions on the blog? Everyone's clear? Don't do the blog. No, if you do the blog, refactor, rethink, have discussions in architecture. I think that's important, even with yourself. Like even if you're in a small project, every couple of weeks or so, sit down, look at your architecture, and ask yourself, can I do this in a way that my future self doesn't hate my past self? Kind of, right? Lava flow. That's a beauty as well. And so much fancy names here. So we're gonna go through the other patterns a little more quickly, but I think the blob was a very important first example. So what lava flow is, if you think about, Vesuv, for instance, and you think about how lava flows, at some point it gets too cold for the lava and it gets stuck somewhere, and then other lava comes in and goes above it. But this lava that was there is stuck. So think about this in your head, and now think about old piece of code, legacy code, where no one has any idea what this thing is doing, right? So who has had code in a certain code base where you look at the function, you look at the class, and you're like, what's going on? What is this? So show of hands really quick. Who had this before? We're gonna count 1, 2, 3, 4. Okay, we have 8 people here. Okay, good. So you've seen this before, and you're like, holy shit. And then you go to Git, so you say git blame, and it was you, Have you had this before as well? I've had this before. I was like, this is terrible. Who did this? Git blame. Oh, it was me. Okay. So this happens too. Point of this little anecdote is legacy code is not always code that someone else writes. Legacy code is also code that you write and you forgot about. And this also happens a lot of times. And this is very much also the case for systems that had their roots in research. And guilty as charged here as well. As a researcher, you write code that fulfills a purpose, that shows a certain proof of concept. And then if this code, if people like this code and like what this is doing, you start going to production maybe, and you start building startups and companies. And then this research code, where you once thought it's only proving a point, becomes production code. I'm going back to the script example. The script that I wrote for this one company was just for myself, a little small research project that I said, hey, this could be interesting. Showed it to the manager. He said, wow, this is good. Write a UI, and so on and so forth. But my roots kind of research code stayed in there. I think it's still in there. Right? It's been 7 years now. And it's still used by customers. It's poor customers. But still. So what are the symptoms? Symptoms are usually code that you write in, like, I don't know. It's something that you write for yourself maybe, and you're trying something out. It's something that you hack together because it's only the weekend before the deadline, right? Yeah, I see people laughing, okay. So you have usually undocumented functions, classes, modules, whatever, some unit of code. Undocumented in comments, right? They don't have comments in there, they're not explained. But also the way they are written in code is not clear to anyone else besides you at that point. You wrote that piece of code usually just to prove if something works. It's a proof of concept. Yeah? The naming of your object is wrong, the naming of your functions is wrong. No one has no idea what you actually did. And sometimes in certain ways, you can see it in open source software as well. You have huge blocks of comments saying, this is a terrible hack. I did this because I didn't have time. I'm so sorry. Look at open source. I know about 3 projects that have it in there. I'm very sure a lot of projects have this kind of code in there. And if you ever worked in a larger code base before in a kind of company, there's code in there saying, to do, come back and refactor this crap. Yeah? Usually. And no one does. It's like a comment from 1999 usually. And so what are the typical causes? We touched on this before. It's usually your own kind of research code being from a research lab or your own little research project that moves into production without thinking, how am I going to refactor this? It's a little bit also a lack of configuration management because it's only built for my machine at that point, just to prove the point. You didn't really think about deploying this to other systems. So what this then gives you is a lot of manual configuration, a lot of manual steps in between, and there's no real automation going on, also in testing, unfortunately. It's also that's a little bit stereotypical. So if you think about, if you ask people, how do you imagine a computer scientist or a programmer to be, it's the guy in the basement, right? Who writes code all by himself and never talks to anyone. Which we all know, of course, is not the case. Software development is a very collaborative, very people-driven approach. But sometimes this happens too. Sometimes there's this one guy who's a genius, right? Not really, but who has certain abilities, and he or she doesn't let anyone touch on their code. And this lone wolf driven development leads to those kind of code pieces where you have a function that has 2,000 lines. Not kidding, saw this before. With no documentation, the variables are named X and Y and Z, right? Okay. So this thing happened. And last part, going back again to my example, the uncontrolled distribution of unfinished code. This is what happens a lot of times. You write something for yourself, you show someone because you're proud of your things, of course, right? And then they're like, oh, we're going to use this for our next product. And then it goes out to people, and you're like, no, this shouldn't go out to anyone besides me. But it does, okay? Anything you want to share, guys?
I've heard of a master project where one they had to code. There were 4 people. They had to program something, and one of them named all variables like Martha, Heinz, Hans, and so on.
Was there a special reasoning behind that?
No, maybe he just wants to be funny, but I don't know.
All right, lesson learned. Don't name.
Absolute code.
Yeah, exactly. Yeah, so don't name your variables Marta or Heinz or something. Use better names. Like Jürgen. No, I'm kidding. Okay. Oh yeah, perfect example, guys. This class was written by someone earlier, Alex maybe, to manager the indexing or something, maybe. It's probably important. Don't delete. I don't think it's used anywhere, at least not in the new microindexer module, which may actually replace whatever this was used for. Right? I mean, it's not the first time I've seen stuff like this. So who has seen comments like this? Show of hands real quick. Lucky, only a few of you. If you start working as a software developer in companies, you will see stuff like this. Okay? Don't be surprised. It's funny. It's funny, right? But I can totally see this happening, even in master projects. But usually this stuff happens if you've been in the project for a couple of years and people change in projects, and this code was written by Alex, maybe. Yeah, there was no Git playing at this point. And there's typos in there too, by the way. Index fiame and stuff like that. Okay, whatever. Anyway, let's move on. Let's move on to more serious things, okay? Oh, okay, of course. We talked about this maybe a little bit. How do we deal with lava flow? Have a proper architecture before you develop, of course. But as we heard before, this is not always possible, maybe, or maybe your systems grow organically. And so what again needs to happen is a reevaluation of what you did. And if you already are in a huge project, you have a million lines of code already, it's legacy, then there's an own research field called system discovery in software architecture. And this is the process of finding the piece of code or the piece of components that are actually necessary to still have in the code base. So what this does is remove that code or find code that is actually used by people. So maybe it's not that code, maybe theoretically there's paths to lead to that code, but dynamically, if you look at how people actually use the software, certain modules have not been used in years. Seen that before as well. So the system discoveries is a really cool research topic where you actually find things that are important in your architecture, and that's important as well. And this whole reevaluation phase is, of course, code reviews. So if you start a new company, I think this is a very important piece of information to ask in an interviewing process. How do you reevaluate your architecture? How do you reevaluate codes that someone has written? If the answer is we don't, we never do code reviews, we never look at code that other people write, that's a red flag, I think. I think if you want to be in a serious company, in a serious operation of software development, there needs to be reflection of what people write. If there's an engineering culture going on. If it's just we build apps and because it's hot right now, we don't care how we build them, then maybe that's cool. For a certain amount of time, you can learn something. If you want to grow as a software developer, there always should be someone looking at your code and people who are willing to tell you that you're terrible, especially in the beginning. They're going to frame it more nicely. They're going to be like, oh, I did this before as well, you should do X and Y. But this conversation should happen, right? And of course, there are no exceptions to lava flow. That's what people always think. It's a throwaway prototype. We're going to build this now for the presentation. We're going to show it to people. They're going to throw this away. And usually people like this. And they're going to be like, hey, can we have this in production in 3 weeks? And we're like, no. Come on, we can do it. Okay. So this is usually how we start out. But if you certainly know you're going to throw this away the next day, go ahead. Hack it up. Try something. Sure. And the other part is rapid prototyping. In the day and age of of frameworks like Rails, or I don't know what was out there with the cool kids now, something with Clojure probably, or Haskell. You can do rapid prototyping, so you can build up a certain prototype to show to people, to have some kind of proof of concept, and then you can throw this away as well. All right, let's move on. Are we getting more serious now? Ooh, spaghetti code. Yeah. So we're gonna go over this quickly. Spaghetti code is what I touched upon in the blog a little bit. It's where you mix in a lot of stuff that shouldn't be mixed in. You have your controller, which does basically connect to the database, connect to the Twitter service to mash up some tweets in there, goes to your message queue and puts some stuff in there for something else, and in the end displays the whole thing. So that's basically spaghetti code. I'm hearing Node.js. No?
Yes, we have we have a project right now where our whole code is located in a single JS file, but it's still a very small project.
So how many lines of code do you have now?
What? Not too many. Not too many. It's a few.
Few thousand, right?
No. It's very small. What? 200 maybe. It's a single Node.js
right.
that does something.
You're on the verge of.
But you should start.
Start reevaluating. If it's for a master project?
No.
Oh, okay.
It's actually it's for this lecture here.
Oh, is it? All right. Good to know. I'm not looking at the code there, so it's not my concern, but yeah. So what spaghetti code is basically, as I said before, you're tangling in a lot of concerns. It's always comes with kind of this blob example. So if you think of spaghetti, a blob usually has spaghetti code, and vice versa. Usually if you have spaghetti code, there's some kind of blob type things in there. So you have no modularity. You have poor organization of your code. You have no idea what's going on where. You have long functions and poor naming. Martha, for instance, right? And this usually happens if a lot of people go into a project and work on this with different coding styles. There's no organization between the programmers. No one knows what's really going on. And the problem with this is, we had this before, there's no unit testing where there are no units, right? Keep this to heart. If you write software, have in mind at least, how would I test this code? Right? If you don't do test-driven development, I think not a lot of people actually do. But at least have a test-first thinking in designing your software. If you write certain code, think about how would I test this automatically, right? So if you don't do test-driven development, I don't, right? Other people do maybe, not a lot actually. But at least have, in designing your functions and designing your classes, at least have the thought of, I need to test this at some point. If I want to do this, does my function hold up? Can I do this? Do I have the right abstraction? Do I have the right parameters going on? And stuff like that. But this is very much related to the blob. Okay. Yeah, so the causes here are inexperience, definitely with OO design. You have no idea what you're doing. There's lack of guidance and code reviews, that also. Because if you do stuff like that and it goes into production and no one tells you what you did was terrible, how would you know? It works, right? For a certain time. And yeah, the things we talked about before. You have a simple script that grew into an application. You have the lone wolf driven development paradigm where people work in isolation. No one is really concerned with the code they're doing. And the solutions again are solid, for instance, or the things we talked before. The use of well-established frameworks. If you use the Rails framework, for instance, or the Spring framework in Java, they do give you some kind of structure into the code anyway. If you use PHP in the mid-2000s, there are not too many frameworks going on, and what you do is write spaghetti code, as we did in the company, my first company that I worked in. And continuous refactoring, of course. Code metrics, I don't know if you've heard about code metrics before. Those are instruments where you can measure certain things about your software statically, but also dynamically sometimes. They give you an indication that your software is crap. Okay, they tell you It's too cohesive. You have too many responsibilities in there. One thing I didn't mention before. Oh yeah, that's the best thing about spaghetti code and about code in general. I'm going to rant about this later on. You have global state. And if it's one thing that you remember about this lecture today, do not have global state, please. Okay? So what do I mean by global states? If you think about Java programs, for instance, now, it's usually that one static class where you thought it's a good idea to save some data that you can use in functions. Okay? Because it makes reasoning hard. If you have a function or a method in a program, and it's built like a function in mathematics. If you think about your math classes and you think about mathematics in general, a function is you have certain parameters, and every time these parameters come in, a certain output comes out. That's a mathematical function. It's a pure function. What global states do is it makes a pure function impure. So what happens is if you have dependencies somewhere else, the function that you're looking at is not always responsible for the output. So you can have the same parameters coming in on different times, and you have different outputs. Although you have the same parameters, try debugging this. It's horrible. Of course, you have to have global states sometimes. If you touch the file system, if you touch the database, for instance, if you touch external services, you do have some kind of state that you have to maintain because this is something that's coming from outside. Yeah. But if you work on a function and you have some static class somewhere saving some data for you, this is the most terrible thing you can do to your program, because random things happen basically. You look at your function and you have no idea what's happening because we're going to look at this later. You have so many dependencies coming in, but this is a certain topic for the later part. And we went through all of this. Of course, the software engineering process helps. Yeah. Yes.
I've actually once gotten a recommendation. I was working on a payment solution in Android.
Yeah.
And if you have to pass certain objects or data between different activities, so between different UI views, Android has some built-in methods for that. But if the objects you want to pass are more complex than just primitive types,
right,
it becomes a little bit difficult.
Right.
You need to serialize or do things like that.
Yeah.
And the recommendation I got from experienced programmers in the company was like, well, just use a static class, put this into that, and in the next activity you get it from the static class again.
If you think back about the definition of anti-patterns, it's things where you think it's a good idea, but it has negative consequences. Okay, of course, this immediately helps you. You know what's going on. But what the static class does is, as soon as you change one thing about that static class, a value or something that you depend on in the future, then the whole reasoning goes out the window, sorry. The toilet. But the thing is that reasoning becomes so much harder if just random things pop in from different parts. We're going to see a beautiful graph later on about singleton. So this is exactly where your thing comes in. Because global state usually comes through singletons. So just a quick show of hands, who knows singleton as a pattern? Everyone. Almost everyone. Okay, everyone. Okay. So, question number one, isn't singleton a design pattern? Right? Haven't we learned this as things we should do? And officially, yes, it's a design pattern. People, in so many books, singleton is like, yeah, you should use singleton. It makes things easier, right? As you said before, experienced programmers say, yeah, use the static class. It's fine. It's good. And that's why it's so dangerous. People think maybe I'm opinionated, so take this with a grain of salt. I'm a little bit opinionated on this topic, okay? So read yourself about singletons, but what I can tell you is it's a dangerous thing to have in your project because it's a dependency that you forget about very quickly. If you can quickly spawn up a singleton, get it from somewhere in your code base, you don't know really where it comes from. Number one, it's bad for concurrency because you don't know how to really synchronize those stuff. And number two, it's another dependency in your project. If you have a project with, 20 classes, okay, it's fine. If you have projects with 2,000 classes and those 2,000, 100 are singletons that can come from anywhere, then it's terrible about reasoning about this software. So if you recall the singleton pattern, it's a single object is instantiated only once. So that's kind of the promise of this. So you can only get this once. And it's a global, that's the problem here. It's a global access to a resource. It's usually database and logging. And I think in logging it's okay to have a little bit like this, but if you package it right. But if you have global access to things like databases, or in your case, to certain objects that you depend upon, it becomes hell for a certain reason. And there's a friend of mine from Vienna. He's a software craftsman. He's been working for IBM and other companies for over a decade now. And he wrote a blog post that I want to reiterate here. It's called "Singletons Are Evil." And let me quickly talk about why singletons are evil. And the problem is that they introduce global states. And with global state, we already talked about this now, they hurt readability because you don't know where certain dependencies are coming from. Unknown dependencies. If you look at a function and you have a function with a name, the name is an indication of what the function does. You have parameters. The parameters are indication of what the function does. The parameter types are indications. The return type is an indication. You kind of have a feeling what this function does. When you look through the function, what's going on. If you have a singleton in there, it's a dependency that you didn't know about. It's a surprise, right? Because usually if you think about a function, you think about reasoning in computer science, what you have is you have certain inputs that produce an output. If you have a singleton or multiple singletons in there that can come from anywhere basically, the reasoning becomes hard. And I'm going to show you a quick graph of a real project going on. Yes.
A small question, but if for instance I have a function and I have 2 or 3 parameters and I need a database access and then it calculates something and then returns something.
Right.
So your advice is to put also an object of database connection into the parameter.
Depends. In object orientation, it's a little more difficult than that. What I advise you to do in this case, have organized objects. But I'm going to come to this later in the next slide. I advise you not to have this database connection come from anywhere. If the database connection comes from anywhere in the code, it's just a dependency you didn't know about. If you explicitly have the database connection as a property of your class, and the life cycle of this database connection is managed, as for instance in the Spring framework, what you do is also have singleton, for instance, if you remember the Spring or you know about Spring, you have an annotation, and in this case it's a different kind of singleton because it doesn't come from anywhere. You don't just get a dependency from anywhere. What you have a life cycle of objects, and as soon as you have a life cycle, reasoning becomes easier again. You cannot avoid having dependencies. What you should avoid is having dependencies that are not visible or clear at first sight. So that's kind of the thing here.
Would using dependency injection, like in this framework like Spring, would that be a good idea?
Exactly. That's the solution to this, dependency injection. Because then the dependency is visible. The problem with singleton is the dependency is hidden. And you don't know where it's coming from, basically. And it can change anytime. If the dependency is explicit, and you know where it's coming from, you have a life cycle behind that, as in dependency injection, then this gets manageable. It's easier to reason about. Concurrent programming gets harder with singletons. We talked about this. So if you think more in detail, this also makes testing harder. If you have a database connection that comes in through a singleton, then if you go into test mode, if you want to test this, what are you testing against? You don't know what, the singleton is not in your control. You're getting this singleton from somewhere. It connects to the production database usually. So how do you solve this? You usually solve this if you have a singleton through configuration management. So you inject a different XML file or something. If you want to have, if you want to do mocking, how would you do mocking if you have a singleton? Let's think about this. You get this object from somewhere. It's exactly this object. If it's a database object, very good example, you can't mock this. You can redirect to a different database, test database for instance. You can't redirect to an in-memory database to have fast tests. So as soon as you have singletons in your code that do not have a life cycle, that you not inject, it's a dependency injection, you have an issue with testing. And that's for my colleague here, for instance, and it's also right here, you have too much of coupling in there, you can't really test this properly. And if everyone looks up from their laptops really quick, this is an actual dependency graph. And the red things are singletons. Holy shit, indeed. So try reasoning about this program now. Yeah, if you have one dependency and you know where this dependency is coming from, and you have 20 classes, sure, it's fine. Then you have your database connection, you know about it. If you have, as in this case, 2,000 classes, and I don't know how many singletons, you can take a wild guess yourself. Then reasoning about your programs becomes immensely hard or impossible sometimes. And this is how a lot of things break. So if you take one thing out of this lecture, number one is don't use singletons. No, use singletons, but have dependency injection on them. Make it clear where those objects are coming from. Yeah, so what, again, the thing before, what are the typical causes? It's taught as a pattern in schools and universities, so it's ignorance, over my part. And of course, it's convenient. So, perfect example from you before, the experienced developer told you, just use this static class, just use this global state in here, because it's just easier. You don't have to pass around stuff, you don't have to do the hard thing. It works, it's easy. That's kind of the thing I took from your example, yeah. So how do you refactor this? Dependency injection, good thing. And there's a nice blog post on this. I recommend to look at this. And remove the global state. Always remove global state that you're not aware of. If you have to have state, make it explicit. If you have to have state in there that changes the way your function behaves, in order to increase the ability to reason about this, have it explicit. You know? Have it as properties in your class. Have it as parameters. Make it convenient for yourself and your future self. So avoid global state. That's the one thing I think that's more important than singletons. Singletons are just the evil, let's say, actor of global state. And of course, we talked about this. There are known exemptions. There are managed life cycles. So if you look at the Spring framework and also other frameworks, they manage this life cycle of I have to load certain singletons or states, and this makes it again easier to reason about because you then have properties that you can work on. You have some kind of visibility, but you also have the ability to inject different functionality if you want to test, for instance, if you want to mock. All right. Oh man, we're bad in time. So how long do we have? Until 12, right? Yeah. Is that okay for you guys? Yeah. Okay. So we have half an hour left, and we have. But the other things here can be dealt with a lot more quickly. So we're going to talk a lot of, again, very nice names to this. I can see you guys laughing a little bit, especially the Swiss Army knife, right? So the Swiss Army knife, just touch upon, is just you do too much, right? You have too many things you do in one. But we're not going to talk about this. We're going to talk about vendor lock-in, and we're going to talk about reinventing the wheel. We're not going to talk about the grand old Duke of York. I'm sorry. So you can just look it up. So vendor lock-in. So who has heard about vendor lock-in before? Just a quick show of hands. Only 2 people? Really? Okay, good. Then let's talk about this. This is very important. So vendor lock-in. So a vendor is someone who offers a certain service. A vendor could be Amazon. Just a quick question. You're doing Amazon EC2, right? In the lecture. Yeah. Okay. So Amazon is, for instance, a vendor. IBM's a vendor. Microsoft's a vendor. Just companies offering certain services for certain things. In our specific case, it would be, in the example of EC2, it would be a cloud hosting provider. In other cases, it would be, at IBM, it would be middleware, for instance. You use MQ series and stuff like that. So vendor lock-in is basically the huge dependency of a specific vendor's proprietary, not open source usually, implementation. Because if you build stuff around a certain ecosystem, you're locked into it. If you use Amazon EC2 and you don't have the proper abstractions in place, you're not going to be easily able to move to Google Compute Engine or to Rackspace or to somewhere else. It might be a little harder. In Amazon's case, it's a little easier because they give you the possibility to have some kind of abstraction on certain behavior that they offer. If you look back 30 years or 20 years into IBM's MQ series, for instance, or other stuff like that, there was a huge vendor lock-in there because they offer functionality others didn't offer in a certain way they designed it to. This is also true for Microsoft, and this is also true for Oracle and stuff like that. So all those big companies very much intentionally have this in place, this kind of vendor lock-in, because they want to keep you as a customer, of course. They want to keep your revenue, your money. And so, so the software development and maintenance cycle is driven by the commercial cycle that those companies have. So if they move on to different programming model, for instance, or different way of doing things, you have to move with them sometimes. Because the new version of certain middleware or certain software that you use fixed a lot of security issues, fixed a lot of other issues, but it changed certain things. So you have to move on with this vendor. Your software does not depend on things that you have in control. And the other thing about proprietary solutions is, which is also connected to the not invented here, companies think that they know better than standards. And sometimes they do, sometimes they don't, of course. It's a matter of perspective, I think. But in many cases, you cannot move from a certain vendor because they don't use open standards. And Microsoft was a very prominent example of this with the Internet Explorer, actually. If you built, and that's, maybe you don't know aware of this, that was a huge problem for many enterprise companies. Many companies built their software around Internet Explorer 6 or 5 back then. And then moving to 7, 8, or even to other browsers was greatly impossible or involved a lot of cost. Now we have a different mindset about standards in browser communities, but the problem still prevails. I know of enterprise companies that still have their software on Internet Explorer 6, right? Yeah, I see people saying yes to this. Yeah.
Maybe a quick comment. Like it's a similar thing is happening right now with WebKit, I think.
Yeah.
Because they have many like proprietary standards, so
right.
It's like that only they implement them.
Exactly.
When coding a web app, I think people should like watch out for that.
Exactly. It's not as bad as the Internet Explorer 6 era. So that was like the most terrible thing that happened to the internet, basically. Okay, Microsoft shouldn't hear this, but okay. Anyway, definitely WebKit is up there. So if you use things that only this one browser can do, then you're locking your users into that one browser, and that's an issue. And the typical cause is, this is very funny because I've seen this in action. The product is selected only based on marketing and sales, and not. That's an issue about big companies. The people that have the decision power in companies are usually the ones that have the money. So if you decide on certain things, you do not consult the CTO, you don't consult the software developers or the architects. Usually the CFO decides what software and what infrastructure you buy, and that's an issue. They usually have their consultants with them, but then, this is a true example, it's so funny, you go out to dinner with those marketing and sales guys, and the next day you have 20 Cisco routers that you don't need, because they have their own tactics that lure you in, and of course, if you have a couple drinks and you're good friends with a guy from Cisco, or other companies, or IBM, or Microsoft, or Amazon, whatever, then maybe the next day you made a decision that was not based on technical inspection, but rather on different, let's say, decision points. And those are things that happen every day, right? So usually certain things happen not because it's technically the best solution, but because it was the best solution for the CFO, or for the CTO because he knows that guy at another company, stuff like that. It's difficult. So the solution to this is maybe have a more transparent selection process. I think many companies have this in place already, but other companies, especially in Central Europe, I think, still have this let's get a beer first approach. Yeah. And what also is the case is that you have this new solution. Sometimes it's shiny, it's nice, it plays all the nice things. WebKit is one of those examples. I mean, the things they offer are nice, right? and you don't think about how can we isolate ourselves from staying in there. You don't build the right abstractions to say, if I want to move away from this dependency, would I be able to? Or am I too locked in there? And sometimes if you're in the case of, let's say, SAP is a great example. So who knows SAP? Many people. Everyone. So SAP is an enterprise resource planning software. And what they have is they even have their own programming language. Yeah, they have ABAP. And if you go for SAP and you want more than the standard, what you usually do is you build upon their programming language to build new things in their software, and then try moving away from SAP. Pretty much impossible, right? So sometimes application programming requires just this in-depth knowledge about a product, and in the case of SAP, it's you need to know this programming language. Although they moved on to having Java now, but a long time they had, or they still have ABAP, whatever it's called. And so a solution to this kind of is having an isolation layer between your application software and the low-level infrastructure, if that's the kind of software you're building. You need to have the right abstraction in place to say, I can do this different ways, but I'm going to abstract how exactly I will do this. Okay, if you're going to do autoscaling in Amazon, then you can use Amazon's interfaces directly, or you have a layer between that says, I want to scale up. I want to do X, Y, and Z, but I want to have different possibilities for implementations of this. Yeah, and there's FUD. So who of you has heard of a FUD before? FUD? No one? Okay, so it stands for fear, uncertainty, and doubt. Yeah, people are afraid of trying solutions that they believe in sometimes because nobody ever got fired from buying IBM, right? The same, of course, applies for Microsoft, EC2, Google App Engine, SAP, and stuff like that. So many times this vendor lock-in also happens because you're not getting fired for buying big company software. The decision was not, we're going to go for that startup that does things maybe better, aligned to our vision and to our strategy. The decision is more on, how do I minimize my risk of getting fired from this company when I take this decision? Okay, last one in this block, because we're quick to finish now, reinventing the wheel. And we talked about this before. Reinventing the wheel basically is there's already a solution out there that would fit to our problem. This can be a library, this could be software, this could be modules they can buy to certain things. But you as an organization decide to build your own stuff anyway. And this can have several reasons. The reason being that, of course, you have this unique problem no one else has. You cannot solve this with certain libraries, with certain modules and stuff like that. And in 99% of cases, the answer is, you're not that special. Okay, forget about this, you're really not that special. Unless you're building software for NASA or other very specialized companies, probably your problem is not that unique. Probably there are frameworks out there, the libraries, there's software that can help you, and they should help you. So, yeah, there's certain things happening here. We talked about a lot of this before. Just read it afterwards. So basically, for you to think about is, if there's a problem at hand and you think it's so unique you have to invent your own solution for whatever reason. The reason maybe being you really think it's that unique, or the other reason being it's fun to build stuff, right? And it can be fun. And in a university context, it's totally fun, I think. If you want to build that new search algorithm, do so. Sure, it's great. If you want to build your own, let's say, security implementation of something, yeah, go ahead. It's a university context. You maybe do have the time, or you do need to practice for certain things. If you work for a company, first of all, never ever build your own security packages. You're gonna fail miserably. There are computer scientists out there who are building this stuff for years and they fail. Don't build your own security stuff. Use libraries. Number one. Number two, use libraries whenever it's possible, right? in the end, you're fulfilling a certain business purpose. So get there with the least amount of risk possible and the least amount of friction. So use things that are already there, even if it might take some customization and it might take some little bit learning into it. It takes a lot less time to learn parameters of a certain library and certain software than reinventing the software itself. Basically, you're not that special. Sorry. Sometimes you are. Oh yeah, so we talked about this. Yeah, so how do you refactor this thing? Architecture mining is again a research topic, which basically gives you the information of existing designs that are already in software. Because this is not using maybe external things, it's also using things that someone else in your company has already built. And you maybe have seen this before, you've built your own database connection thing, and it's a nice abstraction where you only get the best things out. And then at the other part of the company, the other team has built the same thing basically. Just a little different, just a little bit. And so if you know what's actually going on in your code base, it's easy to say if you have 20, 30, 40 classes. It's very hard if you have 2,000 classes in your code base. How do you know what's out there? So a research topic in software evolution and software architecture is architecture mining, where you can extract information about existing things in your architecture. And of course, market research. Here, ignorance comes in. Usually people build things because, oh, I didn't know that existed. Come on, school that. Okay, so research and make or buy decisions should be in the software engineering process. So if you're in the process of designing your solutions, have some kind of research / a make or buy decision in the process as well. All right, our last part for today. We're going to quickly also talk about project management anti-patterns. Yeah, and then again, beautiful names here. And we're going to talk about analysis paralysis, and then the last point you're not going to find probably in standard literature. This is something that we, as a group, experienced in a consulting gig we had last year. So let's jump right in. So analysis paralysis is most commonly found in kind of waterfall approaches, where you're trying to achieve perfection and this completeness that doesn't exist basically in the analysis step. If you think back at a waterfall, what you have is requirements engineering, then you have your design and your implementation test, and your software is perfect if everything goes right, which never happens, by the way. So the symptoms of this is you have those long phases of project planning, your design, your modeling, and where little to no implementation is happening in between. There's no feedback loop. So what you're doing is you have a 2-month requirements phase, then you have a 2-month design phase, and you have a 2-month modeling phase, and then you start implementing. And then it's like, oh, we actually modeled the wrong things. This is not the thing that people actually wanted. This is very, very common. Probably you've experienced this yourself. You build things and then it's like, this is actually not what I wanted in the beginning. And the issue is that certain design and implementation decisions are made that then during implementation, when you actually build the stuff, you see that it was a wrong decision. But redoing the whole thing takes time, and it's the worst thing you can do. If during the implementation you see that actually having an asynchronous approach to this was the wrong way to go, going back to changing the whole way you design things is very difficult and very expensive. And sometimes that's probably the worst thing you can do is that the analysis phase does not involve user interaction, does not involve the customer itself. So you maybe get the requirements from the customer. That's like the first phase you do, and then you leave them in the blind. You do the design, you do the implementation, test, then you roll out, and people are like, "This is not what I wanted. Can we throw this away right now? Those millions of euros or francs?" And this happens a lot, and has happened in very big companies. So feedback is important here. So yeah, this looks something like this at some point. And so what are the typical causes? It's it's usually management that thinks if we do this kind of waterfall approach, it kind of makes sense, right? If the world is perfect, we get perfect requirements, we get perfect design, we get perfect implementation and testing, and then we roll out and everything is great and everyone's happy. But we do not live in a perfect world. We live in a world where people have very hard time communicating what they want. Other people have a very hard time understanding what people actually want. So that there's this barrier. And if you don't have a tighter feedback loop, if you don't get feedback within the process of building your software or building your product, whatever it is, then things are going to be very painful in the end when you realize that this is not the thing we wanted, or this is not the way we should have gone. And yeah, usually nowadays people know about Agile, and people know about, with the people in the sense software developers know that we need more feedback and more continuously inspection of what is going on. And the refactoring of this is basically what Agile promises, which means that you do incremental development. You don't go ahead and have this huge phase of planning and then try to jump right in, big bang integration. But you do incremental stuff. You have things like Kanban or Scrum or something as a process where every 2 weeks you turn out a new version of software that you can show to people. And then every 2 weeks you talk to your customer, you talk to your product owner or whatever it's called, and ask, is this something you wanted? And if those 2 weeks are thrown away, that's fine. If they say, actually this is not the direction I want to go, that's cool. If you throw away 2 weeks of work, that's totally better than throwing away 2 years of work. And this is what usually happens if you have this very huge analysis approach. And then each of these 2 week or 1 week or whatever you want to have the granularity in iterations consist of analysis, design, implementation, test, rollout. So every 2 weeks you do the whole thing. You do the whole shebang. And that's important. And this also, of course, enables rapid prototyping. You build new versions of software every 2 weeks, every 3 weeks, every cycle you have. Okay, our last point for today. After this one, I'm going to leave you alone. Last point is something that we encountered ourselves in one of our consulting projects that was in the Middle East and Asia. And it was that people thought that process quality was more important than product quality. And that's a very, if you're ingrained into the organization, it kind of makes sense. Because you have this perfect role assumption, a little bit at least, where if I'm in this organization and I organize my process, my software engineering process in this particular case, well enough, then my product will automatically be well designed, will be nice, will be usable, and so on and so forth. So the organization assumes that perfectly following and monitoring this process. So they do have a feedback loop in there. So people think they're doing the right thing. It's not that this is evil or anything in their intentions. But they assume that following and monitoring this process leads to product quality. And what this does is, by focusing solely on process, there's no attention to the actual software quality assurance. Okay? There's no code in this particular case, there were no code reviews. No one looked at test coverage. No one looked at code metrics that were actually important for code quality and not process quality. And this anti-pattern has parallels to project mismanagement. So if you're looking for a standard kind of name to this, it's project mismanagement. This goes a little further than that. So the symptoms are that there's a very highly demanding process in place. So if you've heard about CMMI or ITIL or something like that, it's that. It's that every step of the software engineering process is well defined in advance. Yeah? You as a software developer have little to no say on how you develop the software, which is discouraging in itself, because we're engineers, of course, we want to be creative and stuff like that. Sometimes, in this case, maybe it made sense from a management point of view to really make it really strict. And this is what those frameworks like CMI or stuff like that do. They make the process of getting to a certain place in the software very, very strict. So you only have one responsibility. And this is kind of the issue here, because then the team, staff members, were not dedicated to write software, but in the end they were dedicated to to adhere to this process. Yeah. So what they had in mind, the management gives you a certain goal, and the goal was our process needs to be perfect. And of course, this is what you as a employee of this company kind of assign your effort and energy into. You're like, okay, I have to have this process right, because if I make the process happy, I make the managers happy. If I make the managers happy, they in turn are gonna reward me for this. I'm gonna get a promotion, more money, etc., etc. So, so the focus was on process quality metrics instead of software quality metrics. Very bad thing. And there was no quality assurance in place. Very little unit integration testing or manual testing. And in this particular case, there was no visibility in product quality, because the assumption was, and the assumption might have been correct in other cases, in this case it wasn't, that from process quality, you can map to product quality. If we have the process right, we're going to get the product right, which was horribly wrong in this case. The causes for this are, of course, ineffective risk management. You think that this implication holds true? It didn't in this case. So you have insufficient tests. You have no tooling or process to monitor the quality of the product, only the one of the process. And in the end, for the software developers, if you're only measured by how your process performs, you're going to focus on the process. If you're measured on what kind of product you deliver, you're going to deliver a better product. Of course, there are intrinsic motivations to build a good product, but in this case, people were so discouraged by this whole process monitoring that they also didn't care about the product anymore. The product was just a means to an end. It was a way to keep their job in a certain economy in the Middle East and Asia. So how do we solve this? Practically it's clear. The resources that we invest have to be assured that process is important. I'm not saying process is not important. Okay, this maybe comes across a little bit too harsh here. Process is important, but balance is always important as well. So what needs to happen is we need to ensure product quality, and this happens through having metrics in place that give you a certain indication how your product performs. Automatic metrics like unit test coverage, but also metrics that come from feedback from your customers. Right? If people are happy, that's also a metric that you can use. And you can also formalize this metric in the sense of business metrics, where you can say, if more people buy my stuff, if more people go to the login page, if more people register for my website, for instance, you can get back metrics from your customers. And those are important as well. And of course, risk management. I can't stress this enough. If you don't have risk management in place that reevaluates the things that you focus on, in this case, they focused on metrics that were not important to the end product. If you don't have those in place, then you're basically done. There needs to be some kind of reflection on what you're focused on in your product. Whoa, last slide. Conclusions. Reiterate. Anti-patterns describe a solution to a problem where we think it's actually the right idea to do so, but it has negative consequences. Example, the singleton that we talked about before. And same as design patterns that we talked about in the beginning a little bit, they offer a common name for a problem and a refactoring solution. So if we talk about the blob, now that you know what the blob is, you can look at a piece of code with one of your colleagues or friends and say, hey, the nice blob you have there. There's a certain way of communication that this enables. Last things that I want to give from this whole thing. Number one, because this is like a thorn in my eyes, avoid global state, because then you end up with the singleton graph, saw it before. Global state makes reasoning very hard. Refactor early and often. Reevaluate what you've been doing. Have code reviews in place. Let other people see your code and work you're doing. Get feedback. And last but not least, process quality does not necessarily lead to product quality. Here are a few sources where I have this information from, but a lot of stuff is just me being a bad programmer, but then knowing about it. All right, thank you. And if you have any questions, then shoot right away. Anyone? If there's anything just shoot me an email. On my first slide, there's my email address. We can talk afterwards as well. Thanks.